Welcome back to another video. Today we're going to go over something you've gained exposure to from the exercises, unit testing. We can go ahead and create a new project with the library flag to get boilerplate code for a test. I'll do that right now, so go ahead, go back, and then I'll do cargo, new, tests, and then we're going to pass --lib, and this is going to give us the boilerplate code for a library along with the test included, as we've seen in the cargo crates video. So I'll go ahead and open this up, and we have a lib.rs, and as you can see, pretty straightforward. We have a add function, and then we have these attributes here. As you can see, we have this tests module with this weird syntax config test. This is basically a way to tell our compiler to not include this module when compiling for something that is not a test, and only to include this if we're running tests, typically with the cargo test command. So I'll go ahead and cd into tests, cargo test, as you can see, and this should look pretty familiar to you at this point. By convention, we put our tests at the bottom of each source file. So we'll have all of our code logic up here, and then we'll write our tests at the bottom. Next, we have this other attribute, #test. This tells the compiler that the next function that we wrote should be executed as a test. Pretty simple at this point. Now, how do we tell if a test is successful or not? We have two options, basically. We could either cause the test function to panic or return a result type. We're going to go over the first one, panicking. So here we're using the assert equal macros, and this comes from the assert family of macros, assert, and this is pretty simple stuff, pretty self-explanatory. We're basically saying assert that this equals that. It does a deep comparison. So it doesn't need to be, if you're comparing like two structs or something like that, it doesn't need to necessarily hold the same reference, but the values inside of whatever it's referencing must be the same. So go ahead and do a comparison, and if they equal, great. If not, then we're going to go ahead and panic. And just to prove that this is from the family of assert macros, we can go ahead and write the same thing with assert. We could, and again, this is just an expression that always equals true. And we also have the not equals, assert not equals. So we could say, we can assert that result does not equal 0, which will pass in this case. And thirdly, for these assert family of macros, we can add a optional string here saying why the test failed, and we could say 2 plus 2 failed or something like that. So we could, for example, go up here and say left plus right plus 1, and then we could say our test should, let's say, equal, and then again, there's a whole methodology to unit testing, but that's not in scope of this video. If you feel like it, go ahead and Google what unit testing is and take a deeper look. Or also you can go through the Rust textbook. This is just to give a brief overview of how to use the testing framework in Rust. But in a nutshell, unit testing is making sure that you're covering all edge cases of your functions, making sure that you're getting all the weird inputs, and making sure that you're getting all the expected outputs for a range of inputs for a function. So we should say that test should equal 4, otherwise it failed. So if I go ahead and do a cargo test on this real quick, so you can see failed, and it's going to give our error message right here. This is our explanation for why it failed right there. And again, we're panicking when these assertions fails, and we talked a little bit about panicking, I believe, but panicking outside of a test is the program's way to tell the computer, I have encountered an error and I have no idea how to handle it, so just nuke everything and crash the process. But inside of a test, since our tests are safely wrapped behind this test attribute, the panics are actually captured, and it doesn't actually crash our program, but instead just tells us that our test has failed. I'll go ahead and write a new function here that panics outside of a test. We can create an array. I'll make it static, just because we're not declaring it on the stack or anything like that. So I'll say static my array equals is a U32 with 3, and we'll say it has the values 1, 2, and 3 in them. And then we could write a function my array panic, which doesn't take in anything, and it'll return a static reference to one of the elements within my array. And we could do something like my array. Honestly, this might not work. It should actually, because the compiler doesn't know at compilation time whether. There we go. Now I'll go ahead and write a test that tries to call this. So I'll write a new test function access static array, and we're actually getting to the 5th element, not the 4th, but that's besides the point. So we'll say we call should let our U32 ref equals, yeah, ref is a keyword, duh, equals my array panic, and then we should assert. We don't even need to assert anything, we just want to make sure that this runs. So if I go ahead and do a cargo test, yeah, the compiler's smart enough. I was wondering about that. Okay, this is probably a better example. So instead of doing a static array, which the compiler is going to be smart enough anyways, I went ahead and created a vector, pushed 1 to it, but at run compile time we don't know the size of vectors, so this is legal to try to access index 1 even though nothing exists at index 1. And if you remember, we could use .get, which is a lot safer than indexing manually, but this proves that we're able to panic if we get an index that does not exist. So I'll go ahead and save this, and we just have my vec panic down here, and I'll do a cargo test. So you can see failed, both this one and that one, and it gives us a pretty nice error message here. Arnold thinks it's a nice error message as well. Again, it's worth mentioning here that we're using public with these because technically we need to expose them to this test module. That's what's happening with use super here, is that we're actually gaining access to this outer scope right here. So we're getting access to both add and my vec panic through this use super, and again, they're public. Now let's see what happens when I use this my vec panic in a binary crate. So I went ahead and created our main.rs here, and I'm importing it, and we have a function main, and we want to call my vec panic. Let's see what happens when I do cargo run here. And as you can see, we get a panic here, and it gives us a little bit of information about the panic, and we can indeed pass the environment variable rust back trace equals 1, and we'll get a little bit more of a detailed backtrace as to what's exactly going on, although this can be a little confusing to look at if this is first time looking at Rust back traces. But as you can see here, our issue is in our tests main and 4.5, and that's where we're calling myVecPanic. If we're writing a test that's supposed to panic, we can add the attribute should panic to our test function. And as you can see from myVecPanic, that was panicking before, but if I do cargo, or failing before, if I do a cargo test again, our adder, or its works function, is going to pass, but our bad access one actually is, and Arnold is closing the door on me, but our bad access function goes ahead and passes the testing framework. Just going to go ahead and for this next part fix our add function here, and I'll also get rid of our bad test down here, or what passes now but we don't care about it anymore. If we want to, I did say at the beginning we could either panic or return a result type. We can use a result type within our it works function here, so I can say return a result of either nothing, or we want a string for an error, and then we'll go ahead and say if result equals to 4, then we want to return an OK with nothing in it. Otherwise, we're going to return an error with 2 plus 2 does not equal 4 here. And of course, toString. And it was bugging at me because I didn't have this wrapped in an else block. Rust compiler is strict about that because I was either going to return OK, I didn't have an else block here, and it could have kept going on and returned something else, but in this case, the Rust compiler would be a lot more happy with me if I did if and then else instead of if and then return, like so. So I'll go ahead and revert that. And if we do our cargo test again, okay, great, works. And I don't know why it's trying to run source or tests in main, because we don't have anything specified there. But anywho, our it works. If I do left plus right plus 1, then we're going to get our error message. As you can see, failed with our error instead of panicking this time. 2 plus 2 does not equal 4. Now, why would we write tests this way? It seems a little bit more cumbersome to write out a test using if, else, and then return OK or error. And the reason for that is because it easily allows us to pass errors up and not have some obscure panic deep within our code. This is a result allows us to pass up errors, and same with option actually, with this question mark operator. So I'll go ahead and create a new module here. Call it file.rs, and I'm going to yoink this code, and I'm going to go through it, and then also include it in our library here, so mod file. So we're configuring a test here, and what we're saying is we're going to use the file system module itself. That's just what self stands for in this case. It's not an instance. It's actually just the, as you can see, the module itself. Just makes it a little bit easier if we're using a bunch of types or what have you in this module. We can reference the shorthand this way. We're going to use file, self, read, write, and we're going to go ahead and, oh, yep, bad quotation marks. And this is going to test our file persistence, and we're going to use the result type for this. So if everything goes okay, we're not going to return anything. Otherwise, we're going to return an IO error. And we have this quotation, or not quotation, a question mark operator here. And that's basically doing the same thing as calling unwrap, which, as you can see from the documentations, returns the OK value. And again, this works the same way with options as well. So if we had an option instead of, and if you remember, options have either the sum with value or they're none, it's going to unwrap the sum value. Otherwise, it's going to return short, do a shortcut and return none for the current function. So anytime that you're using these question mark operators, you gotta return the appropriate type, whether it be a result or an option, and then the error or the none value gets handled up by the next higher up function or method in the call stack. So we're going ahead and creating a file with the given path and then write to it, and then we're creating a buffer and reading from our newly written file, and it should print out hello Rust, and then we're going to remove the file. I'm going to assume this doesn't work because I don't have the test folder, and I kind of don't want it to work so that we can see exactly what happens when I do this. So I can do cargo test, and then this is the other nice thing about cargo test, is that I'm able to specify which files I want to test. So in this case, I want to test file. And as you can see, it failed. And it gave me a nice message here. And it gave me a lot of detail as well. So like no file or directory. So now if I go ahead and create this test folder here, and I go ahead and do cargo test file, I'm wondering if I have to put in another directory up. Probably not. But as you can see, it passed this time. If we went ahead and did unwrap, for example, then it's going to be a little bit more of a nasty error message, and plus we're not able to like handle it with the next function up, right? So I'll go ahead and delete our test folder again, and I'll run this test again. And it just told us it failed, and we kind of get the same error message, but we don't get a great stack trace or anything like that unless we pass in the backtrace environment variable. But it's just a little bit tidier of a way to deal with errors. If we can handle our errors or our none values with this question mark syntax, then we should try to do that. And it also allows us to chain pretty easily like so. And it's a little bit cleaner to look at and write instead of dot unwrap like so. So I'll go ahead and revert that. And make sure that it's actually a question mark. And in a nutshell, outside of unit testing, we kind of said this, but we usually use the result type whenever we can to recover from something that might not be like an error that stops the entirety of our program. Like maybe this gets called from another function that gets the result and sees if it's an error, and then we can do something else instead of just straight up panicking. We use panic when our program can no longer continue, and I'll just go ahead and for fun just blow up here. So if we ever wanted to panic manually and not have something else panic for us, let's say we hit some sort of state in our program that should not happen, we can pass in the panic macro and say, this is really bad. And this is going to go ahead and just do the same thing as if our test folder isn't there. It's not there, so I'll move it all the way to the top. And then I'll do cargo test file again. And as you can see, we panicked with "this is really bad." That's it for this video. Be sure to, I'm not going to include exercises for this one because you've been dealing with tests a lot for the exercises repo. So off the hook, I guess, for this video. But in the next video, we're going to finally start with our IO project. So I'll see you then.